Now that we spent all this time in 4.1 learning what a vector space is in the most broad terms, where the objects in the set could be numbers or variables or silverware or anything, as long as they played by the rules, the 10 rules. Now we're going to get specific in 4.2, and we're going to look at two particular types of vector spaces that we care about a lot in linear algebra. One's called the null space, and one's called the column space. And any matrix A has a null space, and it has a column space. So let's talk about what those mean. Here's my little example matrix A. The null space is any vector that's a solution to ax equals 0. All those solutions together form a vector space. The column space all combinations, or maybe a better linear algebra way to put that would be the span of the columns. So the book defines these a little more formally, not much more formally. They say the null space is written this way: null A is a set of all solutions to x equals 0, and then they do some set notation, which doesn't matter. And likewise, the column space is written column A, set of all combinations of the columns of A. In other words, it is the span of the columns that make up A. Okay, so not much fancier than what I just wrote down here. Let's take a look at some examples for my particular little A. So let's get one object in the null space. I'm going to claim that 1, negative 1, 1 is an object in the null space. Let's check that out. If we multiply that by A, should get the 0 vector as a result. Again, we know multiplying a vector by a matrix just means one of the first column minus one of the second column plus one of the third column. And let's see how that works out. That'd be 2 minus 6 plus 4, so that equals 0. And that'd be negative 3 minus 2 is negative 5 plus 5 is 0. Okay, so there's sort of the proof that this is in the null space. You multiply it by A, you get the 0 vector as a result. You should be able to think of one other vector in the null space pretty easily. It's in every null space, which is the 0 vector. 0 vector of the right dimension, I should say. So in this case, objects in the null space are vectors in R3, because we're combining 3 columns, right? So it's also true that if you take 0 of the first column and 0 of the second column and 0 of the third column, that you will get a 0 vector as a result. So there's a check that this object is also in the null space. There are lots of other objects in the null space as well, but there's 2 of them. There we go. 2 objects in the null space. Let's find some objects in the column space. Keep in mind the column space is just any combination of the columns. So one object in the column space would be, would be 12, 4. I just did that in my head. But one object in the column space would be 1 of the first column plus 1 of the second column plus 1 of the third column. And I think if I did that right, that's 8, 12. And that's -3 plus 2 is -1 is 5, 4. Yeah. So there's an object in the column space, 12, 4. Other objects in the column space, if I did 1, 0, 0, I'm not going to rewrite these, but that would give me 2, -3. Each of the individual columns is in the column space by picking some 1s and 0s. If you picked all 3 to be 0, 0, 0 is another member of the column space, which it has to be, right? If the column space is going to be a vector space, the 0 vector has to be there. So notice that objects in the column space are in R2 because they're combinations of columns. The columns themselves are R2 vectors. When you combine them, the result is an R2 vector. Objects in the null space, on the other hand, are in R3 because they tell us how to combine the 3 columns that we have and get a 0 vector as a result. So objects in the null space are that and that. Objects in the column space are that, that, and that. So just a question for you. Suppose I've got A is a 4 by 7 matrix. So objects in the null space are in R what? That's a question mark in case you can't tell. And objects in the column space are in R what as well. Pause the video if you need to for a second. Think about that. See if you can come up with some answers, and then come back and we'll talk about it. Okay, so keep in mind 4 by 7 is 4 rows, 7 columns. So there's 4 rows, 1, 2, 3, 4, 5, 6, 7, 7 columns. So an object in the null space needs to tell you how to combine all 7 columns and get 0 as a result. So null space objects are 7-dimensional vectors to give you instructions to combine 7 columns. On the other hand, column space vectors are just some combination of the columns. So when you add an R4 vector to another R4 vector to another R4 vector, you get an R4 result. So objects in the null space and objects in the column space don't even live in the same universes. unless the matrix is square, in which case they both live in R4 or R6 or whatever the size of the square is. Also means in general, null space and column space don't share any vectors because they live in different universes. If it is a square matrix, they definitely share the 0 vector then at that point, the 0 vector of the same size. Might even share a couple other vectors. Possible, but not guaranteed. So in the next video, we'll take a look at a couple examples.